In this class, we will talk about how do we solve problems on transient response. So, what we have, the transfer function of a system, the standard form for a second order transfer function is given like this: C of s by R of s, which is equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square. So this is the second order system standard form. We need to remember one thing, that from the given transfer function, we can compare this and the given transfer function to calculate omega n and zeta. Omega n is the natural frequency, zeta is the damping ratio. When we do this comparison, we need to also keep in mind that numerator term, this is omega n square given, but this may not be always matching to the constant term here. This and this may not match if numerator is a function of s or something else is there. So this is possible. So while comparing, compare only the denominator. We have to compare the characteristic equation only. So I'll compare with s square plus 2 zeta omega n s plus omega n square, that is denominator of the closed loop transfer function will remain same. So for the given transfer function, whatever is the denominator of the closed loop transfer function, that we will compare with this, and from that relationship we will be able to obtain what is the natural frequency omega n and what is the damping ratio zeta. While giving in the problem, we can have the closed loop transfer function, that is C of s by R of s, directly given, or in many a case they mention it this way: for unity feedback system, open loop transfer function is given as g of s is equal to some value is given. So this is given is g of s. When I say characteristic equation, this should come from closed loop transfer function. So I need to first find out what is c of s by r of s. That will be equal to g of s by 1 plus g of s into h of s. If it is specified unity feedback system, then h of s is equal to 1. So from this, I'll be able to get the transfer function, then compare the denominator, calculate omega n and zeta. Now, what do we have to calculate? They will ask C of t, that is output response. How do I calculate C of t? I will calculate Laplace transform of, this is Laplace transform of C of t is equal to C of s. So what I need to take is inverse Laplace transform of inverse Laplace. Okay, that means Laplace inverse of R of s multiplied by transfer function, which is C of s by R of s. Okay, so whatever transfer function is given, this transfer function will be given to us, or we would have calculated the transfer function by using this if g of s is given. So we'll take that transfer function, multiply it by R of s, and then take the inverse Laplace transform. So we can write C of t is equal to Laplace inverse of R of s into g of s divided by 1 plus g of s h of s. From this, I'll be able to obtain what is the output response. For a standard second order system, when we calculate this response, we will get it as C of t is equal to 1 minus e to the power minus zeta omega nt divided by root over of 1 minus zeta square into sine of omega dt plus theta. This is the equation that I can use to calculate C of t. If it is, this is the response for second order system with unit step input. If input is different, of course the response will be different. In that case, I have to calculate by using this. If it is unit step response and it is a second order system, I can directly use this relationship as the output response. I can directly use this relationship. One more thing that we need to calculate is for second order system with unit step response, how do we calculate percentage overshoot? How do we calculate peak time, rise time, settling time? So for each of them, we have derived the formula and we are going to use that. And when we calculate this TS, we need to keep in mind sometimes they provide the information that settling time for 2% tolerance or settling time for 5% tolerance. Even if they do not specify, while calculating TS, we need to consider one and write it. So when we calculate TS, I will be writing it as 4 by zeta omega n if it is 2% tolerance. I'll be writing it as 3 by zeta omega n if it is 5% tolerance. So when it is not specified and I'm supposed to calculate settling time, I'll calculate settling time as equal to, say if I use this formula or this formula, anything is fine, but we need to specify that we are doing the calculation for 2% or 5% tolerance. So these are the formula that will be required for calculation of or for solving the problems related to transient response. Now if I take some problems, a second order system is given by C of s by R of s is equal to this. So this is the transfer function given. We need to calculate the rise time, peak time. We need to calculate the rise time, peak overshoot and settling time if subjected to unit step input. This is a very important for us. If it is not unit step input, we will not be able to use the formula that we have derived. So it has to be unit step input. Also calculate the expression for its output response. So how do we solve this? First, this is the transfer function which is given. I will compare with this transfer function. I'll compare with this transfer function which is the standard form. We will rather compare it with only the denominator equation, not the numerator one. In this particular case, this and this is 25, this is also 25, they are matching. So I can compare omega n square is equal to 25, but they may not match always. So while comparing, I have to use only the denominator. So from this equation, if I compare from the transfer function that is given, omega n square is 25 and 2 zeta omega n is equal to 6. So omega n square is 25. So from here I'll get omega n which will be 5 and 2 zeta omega n is 6. So zeta I can calculate from here which will be 0.6. Now I need to calculate rise time, peak overshoot and settling time. So what is rise time expression? Rise time expression TR is equal to pi minus theta by omega d. What is theta? Theta can be calculated as tan inverse root over of 1 minus zeta square by zeta. This is also always true. This formula for theta and this formula for omega d, they are always true. Okay. So once we have already the zeta and omega n, we can just substitute the parameters and calculate what is theta, what is omega d. Then TR is equal to, rise time is equal to pi minus theta by omega d. Substitute the values and find out what is TR. Similar way, expression for TP is pi by omega d. This is just substitution. Then peak overshoot is calculated as percentage MP, which is e to the power minus pi zeta by root over of 1 minus zeta square. So from here we can calculate what is the percentage overshoot. Now when we have to calculate settling time, it is not specified in the problem whether we have to consider 2% tolerance or 5% tolerance. So it is absolutely fine if I take 5% tolerance and write the expression as 3 by zeta omega n. But I need to specify here which tolerance am I considering. Because I am writing this formula, I have to write that we have considered 2% tolerance. and this is the expression, and this is the value of the settling time. And the final question what is asked here is also calculate expression for its output response. So for its output response, we have this expression 1 minus e to the power minus zeta omega nt divided by root over of 1 minus zeta square sine of omega dt plus theta. Now just substitute all the parameters and you will be able to get this value. So this is the final expression for output response. Okay. Now if I take another problem here, a system has 30% overshoot. So in this case, we have percentage MP given. We have settling time given as 5 seconds. For our unit step input, we need to determine the transfer function. So first thing that I need to determine is the transfer function. So how do I calculate transfer function? If I know zeta and omega n, then I can write the transfer function using the standard form. So what is the standard form? Omega n square by s square plus 2 zeta omega n s plus omega n square. So this will be the transfer function. I can use this. But before that, I need to know what's the value of zeta and what's the value of omega n. So let us calculate that from these two information given. 30% overshoot and settling time is 5 seconds. Also, they have specified we can assume 2% tolerance. So, for settling time, it will be 4 by zeta omega n. Okay, so once we have this overshoot known, percentage MP is equal to 30%. What is the expression for percentage MP? E to the power minus pi zeta by root over of 1 minus zeta square. Now, this into 100 because it is percentage, which is equal to 30. Now, from this equation, what I can write, this part that is minus pi zeta by root over of 1 minus zeta square can be written as, here it is E. So, it will be ln 30 by 100. Okay, it will be ln 30 by. So now, once we take this from here, we can calculate what is the value of zeta. Okay, so because it is ln 30 by 100, this will be negative, minus sign will get cancelled, and then from there you can find out the value of zeta. So this is the expression for zeta. Once you know this, then use the other expression, other condition that is given, that is settling time, which is equal to 5 seconds with 2% tolerance. So Ts is equal to 4 by zeta omega n. Zeta you have already calculated. Substitute here and find out what is omega n. So you are getting zeta and omega n. Now you can find out what will be the transfer function. Here, because nothing else is specified, we have to assume the standard form because otherwise we will not be able to calculate it. Now we know omega n square is equal to, you have already got omega n square is equal to 5. So you can just substitute the parameters, whatever values you have got, just substitute the parameters and you will get transfer function value. This is the transfer function that we are getting. Now the next thing what they have asked here is, we have to calculate peak time and output response. So how do I get peak time? Peak time we have the formula, right? So peak time is equal to pi by omega d. So using this pi by omega d will calculate and then substitute, you can calculate what is peak time. What is the output response? This is the standard output response equation which we have. Now just substitute the parameters and this will be written as C of t. Remember one thing, this output response is a function of t. So here I should have this t value as is. So this is the significance of this is, if I know a particular time, I will be able to calculate what is the output at that particular time. Okay, so from this we are able to calculate the output response. Taking one more problem, a unity feedback system is given by its OLTF. This is for open loop transfer function. G of s is equal to k by s into s plus 10. So this is given open loop transfer function, but I have an unknown here in this expression, it is k. We need to determine the gain k so that the system will have a damping ratio of 0.5. Zeta is equal to 0.5, I should obtain, okay, For this, what is the value of k? That I need to calculate first. Once I know that, then for this value of k, that means the value of k which gives me damping ratio 0.5, for this value of k, determine the settling time, peak overshoot and peak time for a unit step input. Right? So this is g of s. So I need to get first closed loop transfer function. So C of s by R of s, which is G of s by 1 plus G of s into H of s. But unity feedback, so H of s is equal to 1. Now substitute, you will get this value, this expression for transfer function. Then what you require? You need to find out zeta and omega n. So from here, if you compare, omega n is equal to root over of k. Omega n square is equal to k. So omega n is root over of k. And 2 zeta omega n is nothing but 10. In that, it's specified that zeta is equal to 0.5. So for that, what is omega n? Omega n should be 10. If omega n is 10, then what is k? K is 10 square. So k is equal to 100. Right? Now k is equal to 100 for damping ratio of 0.5. So now what will be the transfer function? Transfer function is just substitute k value. So this is the transfer function. What we need to find out? We need to find out settling time, peak overshoot and peak time. We know the expressions. Just substitute expression for TS with 2% tolerance. If I consider 5% tolerance, this would be the expression. It is not mentioned. Any one you can calculate or both you can calculate. It's fine. Then percentage overshoot, you have the expression. Substitute the zeta value, calculate it. Peak time, pi by omega d, you will get it. Straightforward. If I take this one, find the open loop transfer function of a system. I do not know the open loop transfer function now. I do not know the transfer function now. For the open loop transfer function, we have to calculate, and system response is given with unity feedback, which has a second order. Step response is shown in this figure. What do we understand from this step response? This is increasing, reaching to the peak, then decreasing and going like this. And if you notice, this peak is reducing here. Slowly the peak is reducing. It's actually exponential reduction. It's already given second order, so we know how the response is. Now in this case, it's going like this. This is the peak. It is not unit step, but it is step. It is step response. Nobody has told us it is unit step. Okay? What is the magnitude here? 2. That means it is not unit step for sure. The steady value is 2. So I can say it is a step response, but the final output is not 1. Final output is 2. So what is the input? Input is 2 by S. So R of t is 2 times unit step. Magnitude is double. Okay. Why this is important? This is important because here what do I know? I know from the peak value to the steady value, this difference is what I know. This difference is nothing but magnitude of the overshoot. It is not percentage overshoot. This is magnitude of the overshoot. If I know this peak, I will be able to calculate what is the percentage overshoot. Right? Now, how do I calculate the percentage overshoot? To calculate percentage overshoot, one formula we know, that is for unit step. Otherwise, in general, for any step, any output curve given, I can calculate the overshoot as percentage overshoot as output at peak time. So this time is called as peak time, right? When we are getting the first peak, that is peak time. So output at this instant minus the steady value of output, finally where it is becoming steady. So CSS, steady value of output, divided by steady value of output into 100%. This is the general expression for percentage overshoot. So I will be using this to find out zeta. Here it is second order system. So I know what is the expression of overshoot. We will compare this two and obtain the value of zeta. Now see here. R of S is 2 by S. This I know. What is peak overshoot? It is 2.5 minus 2. 2 is the steady value. So this difference. So that's nothing but 0.5. I have to express in percentage. So divided by CSS. What is CSS? CSS is nothing but 2. So 0.5 by CSS multiplied by 100%, which is 25%. So this is the percentage overshoot that we are getting. And this can be written equal to the expression that we know, e to the power minus pi zeta by root over of 1 minus zeta square into 100. This is percentage overshoot for second order system that we know. So I can now equate this two. Okay. One more important point, while deriving this equation, this expression for percentage overshoot, I had taken only unit step. But this is applicable for any step response. That is because here there is no magnitude related. I am expressing it in percentage. So because I'm expressing it in percentage, so even if it is for unit step or A by S, it doesn't matter. It will remain same. That is why I can equate this expression to this percentage of overshoot. Now from this expression, we can calculate what is zeta. Okay, so zeta we know. Now once we know zeta, there is one more thing required, omega n. There is one more information given. Here it is peak and here it is undershoot, right? This is the minimum value. This can be calculated as peak time Tp, peak time Tp, I write it as pi by omega d. First undershoot, this time, I write it as 2 pi by omega d. This distance multiplied by 2 is this 2 pi by omega d. The second peak will be, this peak will occur at t equal to 3 pi by omega d and so on. Okay, so I can write 2 pi by omega d is equal to 0.2 second. This is the other equation which I can form from the given characteristic curve. Okay, so we can use that. We have obtained zeta. Now Tp is equal to pi by omega d. This is peak time. First undershoot occurs at 2 pi by omega d. So 2 pi by what is omega d? Omega n root over of 1 minus zeta square, which is equal to 0.2. From here we can calculate what is the value of omega n. Now we know omega n, we know zeta. So we can write what is closed loop transfer function. Now how do I get open loop transfer function? To obtain open loop transfer function, I have, this is g of s. H of s is unity, right? So this is C of s by R of s, and that is equal to given as this. Then how do I obtain what is G of s? G of s can be obtained as T of s by 1 minus T of s. This is T of s. So this divided by 1 minus this. If you do that, you will get open loop transfer function as omega n squared by s into s plus 2 zeta omega n. So now you know what is omega n, you know what is zeta, substitute in this expression and you will be able to get what is G of s. This expression of open loop transfer function is again standard. When this is the standard for closed loop transfer function, this will always be the open loop transfer function. You can just have a check. If this is G of s, this divided by 1 plus this is equal to this. You can have a check and it will match. Right? So this is the transfer function for this system, open loop transfer function for this system. So what else is asked? Is there anything else asked? No. Find the open loop transfer function. Only this much is asked. So this is done. Thank you.